machine with these things and that thing. So that is what is given in the process chart. Right? You have the process plan for this one. So there you need to give all this information. Otherwise, your design specifications will not be able to achieve in the practical case. So it will not perform. Sometimes it will fail. It will not perform, and sometimes it will fail as well. So here we have given the tolerances, the limits for the dimensions. There are different ways to give that one. You see one on the rightmost corner in the middle, it says something like 23.6. Some values are there, upper and the lower values are there. Plus value, maybe the minus value. And immediately to the left of that one, you have diameter 1300 or 1130, H10. That is another way. Fits and tolerances are given in different tables, right? Now this, the dimensioning and tolerancing is actually a separate topic. Engineering drawing is one, but you at the end should know exactly the applicable things so that you can apply them in your drawing. It's not only just follow the standard, but you have to see the possibility. Do I need that much of finish or accuracy in this particular part? Right? That is something. And also some machining references are given. In addition to that, you can see some information are there in boxes like. What are these things? These are called geometrical tolerances. The first one is the dimensional tolerances that talks about the size. Second one is a geometrical tolerance, which is talking about the shape. Understand? So usually we call it GD and T. GD and T. Right? So geometrical and dimensional tolerances. Geometrical and dimensional tolerances. It's a separate thing. You separate, the courses are there, certificates are there. If you are a professional got qualified for this thing, you have a huge demand, right? You have a huge demand because you can't miss anything. And all other dimension need to be the same thing. And then of course we have a shaft, for example. Now look at this. I have seen in most of you have produced a one straight shaft. Usually we don't do this. Usually we don't do that. If you take anything, there will be at least some steps, so maybe some undercuts. You decide, because it is your design, which one is the better one. And dimensions are given. Sometimes you can see the dimensions given from one side, and maybe when you go to the other side, it's given from the other side. Tolerances are given. The detail views are given. Can you see at the bottom, there are two circles. That will indicate the, what you call the, so one is at B and the other one is at A. Usually you don't want to write, the label, any texture here. Just you can say A or maybe detail A. Detail A. And also immediately that within bracket you have to give the scale. I have enlarged, right? The scales, for example, 2:1, 2:1, and these scales has to be standard scales. You cannot use anything else. You cannot use anything else. I'll come to these tolerances and everything. And then you can see a different shaft. This is a shaft with an integral gear wheel. Look at how the diameter is given of the gear wheel, the outer diameter. 186 H10. H10 is the value you have to take from the tolerance charts. How much is H10? And there are different types. One is called the hole basis, the other one called the shaft basis. I don't know whether you have gone through these things in the manufacturing lectures, but we need to use these two charts. You are using the same thing, someone else will also use the same thing. So you can interpret how much should be the precision required for this particular chart, and then what kind of a machine that I should use. Tolerance means the variations. Within this, your diameter should stay. And in some other places, you don't have it. You don't have it because it's not that critical. So those things are not that critical. Look at how the dimensions are applied. I mean, they are all in line. Same text height. It's not too big. It's not too small. Except that they use the comma for this decimal separator. But in our country, we use point. Sometimes the plus tolerance and the minus tolerances are given. Maybe in some cases, you give plus or minus value. All these details are very important in order to complete your drawing. So if you have a straight shaft, then there's nothing. I know one might find it difficult to machine that one because the bearing surfaces, you need a bit more fine finish. And then there should be some locations to, place the gear, to position the gear. And even in this one, you can see, though you can't see that one, you can see sometimes it may be very difficult. The details are also given. C is given, B is given, and then what? A is given. Where is A? You can find out from this one. And also what you call the tolerances are also given. Geometrical tolerances are also given. Look at this, some more. And even in this shaft, you can see they're all stepped. They're all stepped. And look at the bottom line. You have given the details of, cross section of the shaft, not the entire shaft. It's not the sectional end elevation as such, right? So this is the cross sectional view at particular CC. This is called the the removed section, right? The other one is revolve section. Means you can place the same thing at the same location. Revolve section, removed section, right? Part section. There are different sectional ways that you can, because your idea is to remove the ambiguity and give as much as possible the accurate information. Okay. So you can observe all these things, study all these things, and then maybe take some features to include with your drawings. What else should I include? So maybe even more complicated thing. There, I want you to notice something. Especially how some of the dimensions are given. Not of course everything, but some of the dimensions are given like that. Can you highlight? Can you understand this? Let me show you. Look at this set and look at this set. This is what we call the baseline dimensions. So you refer to this end and then start dimensioning to this point and then to a different point and also to another point. So depending on your design attributes and design requirements, sometimes you have to use like this. There are so many dimensions over here. If you start dimensioning from a corner, we call the continuous dimension. You first feature, second feature, third feature, fourth feature, and so on. Suppose there is a machining error, slight difference. So what will happen to the end of the shaft? Because all these errors will get accumulated, and then final one will be completely out. Completely out. Or even if you do a mistake, right? The mistake will propagate to the next level. Anything after that, it will be affected. Why? Because you are making a continued dimension. Dimension is continued from where you stop from the previous one. Right? Otherwise, you can see all these details are given. Details cannot be shown in the original. And if you try to do so, it becomes very ambiguous. Right? So you can't do that. Look at this, how many steps are there, and look at even the tolerances. Wherever necessary, you have to give the tolerances as well. Right? So please keep these things in mind. And also look at the shape of the keyway. I saw even in the previous one, you see, look at the shape of the keyway. You should know how a keyway can be cut. What are the different methods available? Rather than just, making a kind of a wide space so that you can place the gear, the key, that's not going to work. You should know, how do I machine this? Okay. So these examples are given for you to go through them and then study, and then maybe if possible apply some of the things over there. Right? Again, wherever necessary. Why these drawings have become so complicated? Because you can't miss a single information. You can't miss any information. So that you have to make it completely, the person, independent interpretation has to be happen. It has to be the same. Whether you read it and interpret, I read it and interpret, someone else read and interpret. If you all know the basics of computer drafting, then we should know that it is be fixed. It should give us the same message, not two things, not three, four different things. Right? So that way you should be able to apply the dimensions. For the gear wheel, or maybe actually end cap, you see how many dimensions are given. But in this case, you can see what tolerances are not given. Tolerances are not given, but of course, in all these cases, they use the comma as the decimal separator. And wherever necessary, you have to indicate the machining areas, material removal areas. There may be some places where you don't want to be done, like machining work should not be this one. And then even when you are creating the sectional views, especially with threads and other things, you have to make sure that it looks like this one on the top right hand corner. All right. So if I just show you now, these are the like the drawings that you should go through and see whether my drawing, can I take anything, extract from these things and then incorporate into your modelings. Don't copy. Right? There's a purpose behind each and every feature. This is what we want to understand. Right? Just because I saw it in some other thing, I'm not going to put this one over there. So this is how we're going to create a drawing in the solid edge environment. You start a new document. What is next step? It's open a new draft document. And then you can create drive views. And here we use what you call the view wizard. You can even drag and drop the part from the Explorer to the drawing sheet. That's also acceptable. But in most of the cases, we use a view wizard. And then create additional views. What are the additional views? Now, there you can generate your what you call the primary views. Right? And then additional views like auxiliary views. So for example, in the picture given, in the picture part shown, there is a surface, slanted surface. That slanted surface, if I want to see something on that as a true picture, not the projections, then I need to see on that particular surface perpendicular to that surface. Perpendicular to that surface. So that is what you call the auxiliary views. Of course, auxiliary views, there are even going different levels are there. And then of course you should know the detail views. You saw some earlier. Maybe there's a small the place where you can't see the details. This is not an excuse. You need to give an enlarged view. Right? You should give an enlarged view. And also remember, these enlarged views also should follow the standards. There are standards to follow. You can't have it on your own way. Then the section views, and then broken views. Sometimes you can't section the whole thing, just a waste of time maybe. Or maybe if you section, you're hiding some of the information. Right? To achieve both, then we can use these broken views. And then the draft quality views means it's not extremely high quality. And also some annotations. Some of the dimensions that we use during the feature creation can be straight away used in the drafting environment. We all need to do what you call retrieve dimensions. And also you can retrieve the other annotations like the front elevation, plan, and so on, things like that. That also is possible. And also use the smart dimension command to add dimension. You can use the solid edge standard dimension tools, smart dimensions, vertical, horizontal, symmetry, or all these things you can use freely to apply your own dimensions. But there's a difference actually. The one that you're going to retrieve from your modeling interface, they usually become what? There are two types of dimensions basically, driven dimension and the driving dimensions. Driven by someone else. So we use what? Driving dimensions. So when you use the smart dimension tool to generate dimension, sometimes it becomes the what? Driven dimensions. Because the dimension I did not extract, I was keeping that one, and then the new one becomes what? Smart. If you use the smart dimension tool, then it becomes driven dimension. And then of course you can put some names into the what you call features. This is what you call the annotations. Anything other than your edges of the part, you can consider them as annotations. Even dimensions, you can call them as annotations. Like these, for example, you highlight something that you want. And then you can have a call out, you see, just a pointer, just a pointer to a certain feature, certain area, maybe a certain corner in your drawing, so that you give even more information than what is available. And also you can see on the right hand side, there is a welding to be taken, then you have to indicate the welding. Right, these are what you call the welding symbols. Surface texture symbol, certain places you need some specific texture required, finish required, that need to be indicated. Otherwise, all surfaces will be of the same thing. If it requires the minimum, that is okay, but quite expensive to machine. Right, and then we go into the other one. These are what you call the feature control frame in dimensional tolerances. Feature control frame, you can see that it's talking about the what? Center, where the center should be located. 0.02 m is maximum material condition. So likewise, there are different interpretation for these frames. That comes under what you call the dimensional and the geometrical tolerances. But anyway, you need to use at least few of them. And center lines in most of the cases will be automatically generated. Some, of course, you have to do it manually. Once you have your drawings inserted, then you can start the annotations. While you are annotating, while you are dimensioning, while you are preparing your 2D drawing, suppose you need to go back and then update your model. There are some changes that you need to apply before taking the printout. So you go and modify some of the features, some of the parameters, some of the values in the modeling interface. So immediately it will reflect in the drawing environment, highlighting with corners or maybe just highlighter that it needs to be updated. Otherwise, you can see this still the gear. So once you have this kind of a symbol there, you can update the views and it will read from your file again. The problem may be, from time to time, you may not be able to do that. So as a entire drawing, you can also update. Otherwise, if there are a large number of components, how can I just do this one for one after the other? And it may not be able to identify this one as well. Right? So if you right click on the menu, the Windows on the SolidWorks menu that pops up from place to place, and then just right click, it will terminate this one. You see, even here, there's something change. It will be highlighted with a frame and everything. When you click on the update button, it will be automatically reflected. Remember, I told you the drawings are standards. If you produce 10 drawings for the same project, or maybe you are working in an organization, there also you produce different drawings for different people. So try to maintain a kind of a uniqueness and also consistency. If you take 2 drawings, the format should be the same. Here in the drawings, we have something called the background. Background is something like you have the cage, the title box, and other things, which are not really the part of your product or the feature, whatever it is. Right? Let's see now. how to do this one? Position the cursor or the sheet tab, that is the lower left hand corner. You have different for sheet one, either your part one, something like this. Right click on that one and then setup. Click on the setup menu item. And once the setup box is open, you can see there's a special page for the background. I'll show you all these things, right? And then you can set the background, and of course you can even edit. And then after that you can close. And also you can create what you call template for these things. That is what I'm interested in actually. So you may generate different drawings, number of different drawings for each and everything. If you start modifying these things, what will happen? At the end, you see that one standard is missing from the other document. Right? So let's you can zoom in and zoom out, and then you can use the fit command to display the entire drawing if you want. And also, I should know exactly when I'm generating. Remember, I'm generating drawing. Is it generated or is it going to generate using the first angle method, first angle projection, or the second angle projection? Oh, I'm sorry, the third angle projection. And then others also will follow the same thing. The what you call the center lines will appear at the same time, or maybe the hidden lines likewise. So this is the settings window. The standard view. Options are available. You can see, you can decide on various options available. And you can see there the first angle and the third angle thing I can choose. Some of the things may be not much familiar to you, but you should be able to understand what it is. Look at the cut hardware section. We have standard components like nuts, bolts, and other things. So when you section, we usually don't section those standard items. Like in the second picture, in the cut hardware section, that is like this. And also, it's not kind of a separate component, but it is integral into that one. Could be a triangular shape. Look at what is on the right hand side. And many of these things are coming like hubs, for example. Hub thickness is very small. Right? Thickness is very small compared to the other part of the part, the body of the part. So these are called ribs, for example. So when you section, ribs will not be sectioned. So you can ask the Solid Edge to exclude them from sectioning. In SolidWorks also we can do, but sometimes we have to go and manually pick. And for other things also we have standard things. Oh, my animation got those others appear before I wanted to do this one. And then I want to get a principal view. So one view is already there, generated from the view wizard, and then click on that one and then drag it. Note you can generate the projected view of this one. This is what we call the principal views. So you can take one view as a reference and then generate all other views. For example, the top view, left view, right view, even the bottom view. And also you can ask for an isometric view as well. If you move your cursor accordingly, like this. So it's not that difficult. But only thing is, you should be able to make sure that these are standards. These things are all standards, right? So before proceed further, maybe I will give a small demonstration on this, right? And also remember, it's very important that you create what? a template for this. I'll show you that one first. Hope you can see the solid edge screen. Right. Now, every time I open a new part, I need to select, for example, go new, and then maybe standard templates, maybe metric or something like this. I'm going to select a part. It's a template actually, it's a template. And every time I open a part with these standard templates, and then I have to modify it. Because my organization has a different format. Right? So, but every time I use that one, maybe I don't know how, other than this, how do I going to get this one? But you can create your own. But you can create your own template. That is what you call the user templates. Here you can see, I show you two things the other day. Right? But let me see, for example, I'm going to use isometric. Isometric, let's say, for example, part. But I open this one. Did I click? Yes, right. So this is what's open. Now there are many things that I can change. For example, if you go to this application menu icon and then you go to settings and then options. Okay, so the option dialog box appears. You can say view the colors, for example. You see, there are many parameters that I want to have it in all my parts, assemblies, and even drawings. So the consistency can be maintained and it is a must. If you see it is inconsistent, then it is not acceptable. It's not acceptable. So whatever it is, you can put all these things. The color, how do I represent different colors for different objects? Saving, and then important thing, file locations. File locations. There you can see there is one place for the user template. Maybe you can have probably, right, with comma separated, two locations. This is where you can save your template files, right? And then even the other things are there. So when everything is ready, all what you have to do is save this one in that particular folder, so that when you start Solid Edge next time with this new button, then you will see all these options. Right. So what I do is I open this file, I change all these things that what I need, right? Drawing standards or whatever it is, I will change all these things. Okay, don't click on the manage if you are running this one, because it looks for the Teamcenter connectivity and it will take some time to say cancel or something like this. So let me see the PowerPoint thing. I will switch quickly to the other one when it is ready. All right, I think you see there's a message. It's looking for the Teamcenter connectivity. If you don't have the Teamcenter connectivity, then of course you find it difficult, right? Okay, so don't go into that one. But you can say units, I can change. Look at these things, right? And dimension styles, I can change, right? All these things first, where you're going to find out help and everything, and then you can say okay. Wait, it's taking time. Make sure that you save your file, right? Save your file before you attempt such things like this, right? I think still you can see at the status bar, it is requesting a list of TCCS environments and something like this. Because in the worst case, you have to restart Solid Edge. So then you will lose everything if you have not saved it previously. And again, remember, save your files in a proper folder structure, right? In a proper folder structure. Otherwise, difficult. Now, this is what I want. See whether I can rename this one. For example, here you can see the file, and then I can rename top. It says XY plane. I'll say P1 top, for example. Right, so it appears over there. I can see here P1 top. Maybe from part to part, sometimes you have to rename your features, rename your reference items and everything as it is. Why? Because if you take many of them into an assembly, and then say, for example, 10 parts, then there will be 10 top planes, 10 right planes, and so on. You find it extremely difficult to identify which one is which, right? So likewise, you can rename. Even if you want to create some features, you can rename them. Then what you have to do is you have to go to the menu and then say save as. You can see here, there's nothing like the template over here. You go to save as, so the template will also be the same. All what you need to do is, so this is my usual location where I'm going to save the file, right? But my templates are saved here in a different location. Solid Edge templates, right? I have created a different folder. You can also do the same thing, and you can, if possible, you can keep this one a copy in your pen drive, so that whenever you go there, you can open it from there. Right? So there is only two parts. I'll say this is ME3200. I'll say parts. That's a template. You look at the place. Remember this place, I defined that one in my Solid Edge options, right? I just save it. So before you start creating all these things, now this is already there. Maybe I can even close this one, because that is the template file I'm still opening, and then go to new, say new. You see here, this is already there in the list. This is already there in the list, right? So then I can open it. So now all my settings will be according to this particular template file, and this is a different name actually, right? Because that's a template. You see here, it says part 4, but look at the plane name, the top plane name, it says P1 top, right? So likewise, you can easily customize and then save them as a template. So next time you just click and then open it. Right? Now I close this one also, and then I will see how I'm going to open a drawing file. Now you go to new again, new, and you go to the standard templates. You can say there are different templates over there. I select maybe metric or maybe isometric, because we are working in what do you call the millimeters, right? And then there are, you can say, many files: assembly file, and then Wellman file, part file, remember, and then draft file. This is the drawing file, right? This is the drawing file. So when you open the drawing file, you can see some preview on the right hand side, right? And then I will, okay, this one, this is isometric. I will close this dialog box. So this is what we have. Standard cage is already appearing over there, and then your revision history on the top right hand corner, it is still not filled, and then you have a border and everything is ready. Right? So you can zoom the drawing, not like in the middle mouse button, but you can use the control key and the middle mouse button, and just middle mouse button, you can drag it control up and down, or maybe even this way and this way, you can see, you can zoom in and out. Zoom in and out. That is called, in the drawing sheet, this is called the background. The background, right? So how do I do that? How do I know the paper size and everything and things like that, right? So I have given the instructions in this particular thing, right? Setting up the drawing page and everything like that, right? So maybe I'll quickly go to that one as well so that you can go into the details. This is all additional views. I will show you that one as well. Okay, maybe it will take time. I'll switch to this one and then show here. If I there's the sheet tab here, right? You can see there's only one sheet. You can add one more sheets over here, right? Still I'm not, what you call, I'm not inserted any drawings from here, right? Right click here, you can say the sheet setup over here, right? And then I click on that one. What is the sheet size? You can say it is A2 wide. You see over there, it's A2 wide. That is the physical size of the paper, that is this border over here. And then the scale of all views generated, except you generate the detail views, will be 1:1 full scale. Or else you can change it manually. But we never use non-standard scales, right? We never use non-standard scales. And if you go down here, you can see also, you don't have 1:3, 1:2.5. I mean, those things, even though it is possible to create manually, we don't do that one. We don't do that one. Right? You can even create some custom size papers. These are standard papers and everything. And then name of the sheet. For example, this is a sheet 1. If you want, I can put any name I want. And then what is the background that I should use here? Remember, the paper size is A2 wide, and then accordingly, I can create A2 size a border like this. Or else maybe I can use maybe different thing, maybe a A3 sheet. Let's try. Let's try what will happen. Right? It says show background. If I clear this one, the background will not be shown. You see, that is changed. If I just go to that one, now change. Right click again, go to setup, A3 sheet, and also you see here, it is automatically changed to A3 sheet. Sometimes you can even change differently. Right? This is the background. If I say remove this one, and then it will be gone. That is, your blank sheet is there. Now you can create your own, right? Without following the standards, Otherwise, if you click here, the background, for example, here, right? Not in other places. Here, if I see the background, you can see some other sheets will be automatically open. Can you see here? There are 1, 2, 3, 4, the blue color ones. There are 4 backgrounds are associated with this particular template. This is A4 sheet. You see over here, and you can see the word background also here. This is A3, this is A2, and this is A1. Right? And some of the things on the bottom right-hand corner with the cross box-like thing, that means they are variables, system variables, so that we can have parameters, and then you can update them automatically. Drawing name, for example, project name, for example, the date, time, and everything. All these things can be updated properly. Right? So let me show you what I am proposing you. Maybe I will share this file with you, but anyway, you have to learn this one, right? You need to learn how to use this one. For example, new, I'll go to the user templates, and then I'll select ME3200. You see draft here. This is this one. Okay, maybe I'll say the first one. Why am I doing so? Because you can see over there, this is that template folder, solid edge templates, and then I have the same file over here. I created the template and then save into this particular location. So next time when I open it, I'll be able to get that one. Now look at this. This is what we want to see. So if I zoom into this part, now this information should be there in your right, and it has to be 2021 actually, right? It has to be 2021 or 2020. Now there's one thing is missing. You can see one of the variables are missing. That is why it says error. There's no reference for that one. Right. So you can take this one and then study it and then try to create your own thing, because at the end when you submit all your drawings, it has to be in a nice and a standard format. If you start doing all sort of different things, then maybe we may not be able to even display to someone else. You can say why, because the drawing sheets view are enabled, the backgrounds are enabled. You can see the additional backgrounds. I'll select this, okay, this window, and I'll right click again and then say edit backgrounds. You can see here, even though you say the backgrounds and then edit backgrounds, I'll be able to edit those things. So what I'm trying to edit now is A3 landscape. You can see the name at the bottom, A3 landscape. You see now all these things can be changed. All these things can be changed. So you have to be very careful and in preparing these things. But anyway, if you set these things, it is only for once, right? It's only once. So if I double click here, you can see it will be, you will be able to edit this one. It's just a text box, right? Nothing else. You can format and do everything. You can see on this one, the font and all these things you can change. This is just a set texting, right? But let's see about what is this one. I double click here. It will give you a kind of a call out properties. We call the call outs. You see here, and there are many properties associated: text and the leader, smart depth, for example, feature call out. You see there are different things over here, the border, and this is what you usually see. What is this one? Origination date. It's a kind of a variable that you have to define. Now maybe you have not defined it, so that is why it is giving you some problems. So instead of that, you can try from here different property text is over here. So for example, revision number, project name, number of sheets, modified by, all these things you can include in that one, right? And also after selecting, you can even select the formatting, how you should format. If it is a date like thing, for example, you see DD and YY. That is the format that we use. So that will automatically format. Right? And if you open a different one, for example, say this one, for example, again you see it says finish, right? What is that finish? Where do I get that finish? If you go to again this application menu and go to info, right? And then say property manager, I hope. Let's try. Yeah, it's asking me to change the document first. I will exit from this. Just go to the sheet tab. It is now over there. I can even hide this one if I want. Let me just save this file. This is my file, right? So you can go into the same thing. Maybe you can save this one as the same thing, right? Because I'm still working in the templates. Yes, all right. Then let's go and try to info and then the property manager. So you'll be able to see that the different properties are there already. Right? Is nothing much is defined. And then here, origination date, you can see here. And then you can create your own, what do you call? But properties you can add all over here. Say for example, settings, I'll say the file properties, not this property manager. I'll go to the file properties. And over here, you can say the summary. And then, for example, the custom, you can see this is the finish, right? And then all what I need to do is, this is, you can change. For example, if I select this, machine and polish, you see, gold, nickel, or whatever it is. If I say copper, it will appear there. And then say modify, it goes there. And then say okay. Right? So if you update your drawing, it will appear over there. So all what you have to do is right click here, go to edit background, and then change whatever the things that you want. You can insert your text or whatever it is. So the reason why I am giving you this file is so that you can learn starting from this point, right? Or in the worst case, you can use this one, but make sure that you learn before you leave the university, right? Before you leave the university. All these things you can try, but anyway, keep a copy, right? Keep a copy. So then I will even you can say here for different sizes, for different paper sizes, right? This is a for landscape, this is a for portrait, A3 landscape, A2 landscape, and then the A1 landscape. You see, the sheet become big, and then the what you call your template become, or the border becomes smaller, right? So once you are ready with your border and everything, I can again right click and say sheet setup. This is A3 paper size. I'll change this one to maybe say A2 or A1, A2 white, for example. Right? I change it to white. And then the background, you can say A3 LS. You see here, size is A2, A3 white. Apply and see. You see now if I fit, your paper is bigger and then your border is smaller. Right? Your border is smaller. There's something wrong. So then I'll go and then sheet setup again. So this is A2 white. See whether I have A2 white. I don't have, yes, A2 LS landscape means A2 white. So good that I have one, then I can apply. Right? So if you create this template, it won't take that much time to generate your drawings. Now, when you create your templates, your dimension styles, the sizes, the appearance, and everything can also be saved with the template. Right? Let's see how you're going to do that one. Now, the first thing is, how do I insert a drawing view into this particular drawing sheets? You see, I have only the drawing sheets open, no part and assemblies are open. Right? So I go to view wizard here, you see here, view wizard, and then wait, it will give you a dialog box, and this is looking for where I have last saved, but I'll go to the place where I have saved the solid edge files. Say for example here, I saved it here, models. You can say different parts are here, right? Likewise, you can go and select. Maybe I'll select I'll select this one, for example, right? I'll select this one and then say open, right? You see, there are certain other things. If you want, you can open as read only. Most of the things are what you call just disabled for the time being, but I'll open it. And then you have some value dialog box here. You can see over here. Now the scale is set to, you can place it over here, right? You can place wherever you want. Why? Because the scale is 2 to 1. Maybe I'll select this one. Scale is 1 to 1. Now it is a smaller one, right? I can place wherever I want. And then by default, it will give you the front elevation. And then, I mean, all these things you can change if you want. You see now, all these things you can change view orientation. You see here, left view, top view, for example, I get the top view, right? And likewise, if I see the front view, I get the front view. Scale can be changed. If you are happy, then you can place the view like this. So immediately after that, you can create other what you call principal views can be created. You can say this principal view is now automatically activated. Maybe let's say I'm satisfied with this one. I select this one. Right? Now it is already there. So that gear wheels is already selected. Right? If I do some modifications, what will happen? Let me open that the gear wheel. What is that gear wheel number 3? I hope, right? Let's try to mouse and open. that is per gear 3 or something like that, right? The blue color one, right? Say open. It says blue color, this is different color, doesn't matter, right? So let me say I will, there is one pattern here. What is this pattern? Okay, that is for this one. Okay, I'll say the pattern 2. That is for this one, right? I'm going to say, for example, suppress this pattern, right? So I have only one. I have only one over here. So let's go back to the drawing view and see. It says, and then drawing view has been changed. Now you see, there's the kind of a highlighting cage over there. So that indicates that we need to update this one. You can update maybe the whole thing here, update views, or you can right click of this one and then update only this one. If we see that everything is to be updated, then you see now it is there, it's updated, right? And then if we want to generate maybe the other views, right? So then I go to what you call the principal views. Then it's asking you to, where is my dialog box? I should appear the message somewhere there. It's asking you to first click on the view, right? I click here, prompt bar, can anybody see this one? Maybe in the other window? I can't look it, but anyway, it says it's like this, right? Click on the view and then you can drag. You can see here either this way, or maybe even isometric views like this, right? Wherever you want, you can even generate the isometric views like that. And then if you want, you can finish, then you can right click and say finish. And let me unsuppress the feature. Unsuppress the feature. So it will appear in this particular window. If you go to the drawing now, you see in both views, you have the rectangular mark indicating that needs to be updated. So if I right click one by one, that takes time. So let's go and try update views. Right? So all views will be updated at once. Now I want what? See, I want to have a sectional view. There's no point of giving the top or the other one, because if you try to give that section view, you can see with all these gear teeth, it's going to be very difficult to understand. Don't produce any view which cannot be read very clearly and then interpret and understand. Right? Okay, you can try. You can select this view, and then maybe I generate over here. You see, this is what it looks like. Right? Even if you remove the hidden lines and other things, you will see still it is difficult, right? So let me delete that one. Just delete key. Now I want to have a sectional view, because section view I can give more details. Here you have a section. When you select the section, it will actually ask you to select a cutting plane. Where is my prompt bar? Should be somewhere either here. It's in the bottom. You can see here. Click on a cutting plane. I hope you can see at the bottom of the screen. Right? Click on the cutting plane. I'll just put it over here. Right? Click on a cutting plane, or you can even increase the number of things, or you can just put it in a floating window. But I don't have a cutting plane here. I don't have a cutting plane here. So I go to home again. I will cancel this. I'll cancel this, and then first create a cutting plane. How do I want to cut the Okay. After that, you click on what you call close cutting plane. Now it's asking which way to view at, maybe on this side or maybe on the other side, this side or the other side. So if you want to generate the view on this side, this has to be the direction, right? Why? Because this is first angle projection, right? This first angle projection. If not, maybe if you want to generate the view on the other side, you go into the other side. So I'll just select this side. Let's see what's happened. Right? What else? Now cutting plane is done. Right? Now I need to go to section again. And then now I can select the cutting plane. And then go to left hand side. Don't go into this side now, because you need to flip the arrows again. There are very, the difficult situations where you have to understand. Just click. Is that all? Yes, fine. But if you zoom, you see you have the section lines, and also you have what? You have also hidden lines, which is very unclear, right? This way there's no use of this particular view. So you select this one and then right click on here, and then you can see there are different things as well. Maybe I'll go to properties, or even there it should be over there. Now there are many things over here. Display, right? You can control maybe the hidden edges. Maybe I'll say no. Let's say update. Let's say apply and see. Now it's gone. I don't want to see the hidden details. I don't want to see the hidden details. And then apply. So this is what you call a sectional view. Remember, the center lines and other things are not yet here, but you can apply all these things. Let me give you one more view, right? Let me give you one more view. I'll say the detail view. Maybe here I want to give the details because it's not visible. And I go to what you call the detail view. You see, click for the first center point of the circle. Maybe I can zoom, for example, because I may otherwise